Hello, everyone. Thank you for coming for our tech talk. So today's topic is called Edge and Far Edge Clouds with k0s CNCF distribution. And let's get started. So first of all, let me introduce myself and my colleague. So my name is Roman Kuzmin. I'm a DevOps engineer at Mirantis. I'm working here for a pretty long time, I would say. Um, and also here, my colleague, Daniel. Um, he's a principal cloud solutions architect. So he's also working for a pretty long time in Mirantis. And today we will be talking about k0s for Edge specifically and k0s in general. Let me introduce the agenda. So the first thing that we will talk about is the k0s itself, what it is, essentially. So a quick introduction to it. Then we will talk a bit about k0s flexibility in terms of configuration, storage, etc. Then we will move on to the k0s features specifically for edge computing. Next is the k0s lifecycle management. I will show you briefly how it is working on the high level of abstraction. Then we'll proceed to the demo. I will show you a couple of features that will be mentioned in the features topic of the day's talk. So let's talk about k0s, what it is essentially. So k0s is a Kubernetes distribution. It is like the simple, solid, certified distribution that works on any infrastructure. It could be bare metal, on premises. It could be edge, which we will talk about a bit, in a bit. Also, it's for IoT and for generic Kubernetes workloads for public and private clouds. So one thing that needs to be mentioned about k0s is that it's completely free for personal or commercial use, and it also always will be free. So it is provided with the core Kubernetes components as a single binary. It is very small, and there is no host operating system dependencies. It could be installed on any Linux distribution, but there is no that the kernel version should be 3.10 or higher. It could be installed in a few minutes, so without any additional software packages. So you don't need to type a lot of commands to install the k0s or like any prerequisites, any packages, etc. So what else? Like, for example, security vulnerabilities can be fixed in the k0s binary. So you can just patch the k0s and just use it really fast and quick. And also you can upgrade your operating system and k0s independently. So it is really, really important to have this, feature for your clusters. Even though it's a single binary, it is still fully functional, secured Kubernetes distribution, which means that you can use it not only for edge or, for like small tasks for small clusters, but it can be also used for production workloads. So let's talk a bit about k0 security features. So first of all, it meets FIPS through Mirantis support. Also to leverage all the CNCF security projects. So any solution could be installed. Any CNCF, of course, solution could be installed on top of k0s without any without need to patch the k0s or do like a lot of configuration stuff. Also, it's compatible with security partners like SysDig, for example. It is compatible with the LAN Security Center. I will talk a bit about LANs a bit later, especially in the demo section. And also it is compatible with any container registries, like including like Mirantis Secure Register, for example. So let's move on to the k0s flexibility. First of all, let's talk about a bit about hardware footprint. So you need to have like pretty low resources to run k0s. And like the cool thing about it, that it can be run um, on different processor architectures, like for example RAM64 or RAM v7, which means that it's like pretty suitable for the edge computing, especially. And also, you don't need a lot of like RAM or storage or CPU to make it work. So if you're working for, if you're deploying a controller and worker nodes, then for controller, as you can see in this table, you only need one vCPU. But of course, like the higher is better. But like the minimum requirement is the one vCPU. For RAM, you only need to have 1 GB, and for storage, about like half of GB will be enough. So for worker node, you need even less RAM, but a bit more storage. And also there is a mode when you can run controller and worker on the same node. Takes like a bit higher, a bit more memory and storage. But anyway, it's pretty low, pretty low requirement. And also it scales like pretty well. You can see in this table that it is it needs like pretty not that much resources, but for a lot of workers, like for example, or number of pods, you don't need like a lot of resources to run, because as I mentioned before, it is just lightweight, but in the same time it can be used for production. So keep in mind that lightweight doesn't mean that it is not like for production, it is not secure or anything like that. It is ready for use, and it's like scales pretty well. So for storage, in terms of storage, we have I have split it in two. So we have like the data for control plane and data for your application that you're running on top of k0s. And for control plane, you have like the variety of different data stores. By default, etcd is used, but you can also use PostgreSQL or MySQL. It will be external solution, but anyway, you can use it. And if you're running k0s in the single node mode, when you have controller and worker on the same node, SQLite is used. And for application data, it can be integrated with any CSI solution. So for example, if you want to use AWS S3 bucket to store your application persistent data, you can easily do this. Or I don't know, if you, for example, want to use RUBSEV, please do this. It is easy to do, easy to set up. So it is compatible with any CSI solution. In terms of networking, by default, we have Browser CNI, but it is only works well only for small clusters. So if you want to run like some critical business critical workloads, it's better to use more more mature solutions for CNI, such as Telco. It is also comes by default in k0s. It is configurable, but also you can use any CNI solution that you want to. So for example, if you want to use Cilium, you can easily do this out of the box. You don't need to do a lot of configuration stuff and things like that. So yeah, it is really easy to do this. So now let's move to the features that k0s has for the edge computing. So, but first let's talk a bit what edge computing is. So it is like a paradigm which refers to a range of networks and devices at or near the user. So edge is about processing data closer to where it's being generated, and enabling processing at greater speeds and volumes, which leads to the greater action-led results in real time. So what you're facing when you're using edge computing, of course, it's limited space, but to overcome this thing, you adapt hardware footprint and adapt CVSCs like storage. Also, what else you have? You have obviously limited power because probably the hardware that you're using is not that major, not a lot of memory and storage you have, and also maybe it needs less power. So in terms of so what we are doing with k0s, we provided a compatible software, so you can, as I showed before, the hardware footprint is pretty low, so you can use it on almost any device. And also regarding limited networking, so probably you will have like not that good network connection to your devices, and k0s shows pretty low latencies because of the how control plane works. So, and maybe you have a question what is the use cases for edge? There are plenty of them. Like you can use it, for example, to process and analyze patient data from like some sensors, some wearable devices, and you want to process them and do some analysis and probably build some graphs or something like that. Yeah, you can see all of them on the slides. I think, and one of the most interesting is the 5G networks, because you need to have like ultra low latency, and it is pretty important nowadays. And also for sensors, for different sensors, and maybe on some manufacturers or stuff like that, you also want to monitor it and do some analysis and all that stuff. And this is all about edge. So there's where you want to use k0s essentially. So, and how k0s is adapted, I already talked about it a bit, but there's the summarize on the slide. You can see that it supports ARM architecture, which is pretty important for for small devices, especially for small devices. It is like has a low hardware footprint and compatible with a lot of solutions for storage and networking. Like almost any CNCF solution for networking and storage will work. It supports flying mode, air gap mode. Now all that stuff is really important for the edge. Yeah, and also I forgot to mention that it is working on Linux, but also it is working on Windows workers. So maybe it is also sometimes important. So here on the slide, we can see like the example of the deployment pattern for edge. So we have different edge sites. You can see it here, like the site 1, site 2, site 3. And they're maybe located in different locations, like for example, one like the site 1 located in the US, site 2 located in Europe, and site 3 located in Australia, for example. And you can all manage them using single control plane. So this is really essentially what is edge about. Yeah, and also you can use different networks, but obviously you need to to have connection between sites and the and the control plane. And for telco, for example, there's the example on the slide. So you can have, for example, x86 x86 architecture, bare metal machines, Linux, and you can install k0s on top of that stack. Or you can pick any any combination that we have here on the slides, and it will work. k0s will work. And also a lot of different application that is really needed for telco will work on top of k0s, such as, for example, Multus and KubeVirt. We will I will show you in the demo section like how it really works on the k0s. So what is sorry, I will talk about Multis and Kubernetes in a bit. But as I said before, you can use there are two modes for installing k0s. One is the single node, where you have control plane and the workers on the same physical node, or you can use like the standard controller and worker nodes. I mean, where controller and the worker are just different physical devices. And obviously you can like secure the network with the firewall rules. So all you have in the like classic Kubernetes distribution, any of them, all these features are supported in the k0s. So this is what is Multis about. This slide shows what is Multis about. So you can, in one pod, by default, one pod has only one network interface. But with Multis, you can extend this functionality and have multiple interfaces attached to one pod. So I will show you how it works in k0s. And also about KubeVirt, it is basically VM management. So you can manage your virtual machines inside k0s itself. And it is needed because some telco edge workloads cannot be easily containerized, and you still have to manage VMs. And obviously, you don't want to have one place when you are managing VMs and another place when you're managing containers. You obviously want to manage all of these things in one place, and you can do this with k0s. So, and the cool thing about Multis and KubeVirt and most of the other solution that it can be used in k0s out of the box. You don't have to patch k0s binary or like rebuild it, anything like that. You can easily use it out of the box. So talking about lifecycle management, we have a Terraform script for creating infrastructure on top of the any cloud provider or even environmental. And this Terraform script will create all the infrastructure needed for k0s and provide output, which you can use with the tool that we have for k0s called k0ctl. So with this configuration provided by Terraform and the k0s CTL tool, you can install your whole k0s cluster in just one command. So it is pretty easy to do. But if you don't want to use Terraform and you already have infrastructure created for the cluster, you also can use k0ctl. So it is pretty easy to use tool where you have to specify only IP addresses and SSH keys to the nodes, and k0ctl will install all that is needed and connect everything together for you in just one line. Yeah, and also we have a tool called Cosmotron or k0smatron. So Daniel, could you please talk a bit about this?
Yeah, sure, Roman. I did share some links in the chat, and you will be able to see the link for k0s and k0smatron projects. So both k0s and k0smatron are open source, so you will be able to see how we have implemented k0smatron. The idea we have behind k0smatron is that we wanted to find a way of handling cluster as a service in an optimized manner, right? So today we know that we have two ways of trying to do the multi-tenancy around Kubernetes. Either we do namespace as a service, so we have one single large cluster, and then we segment the resources for each tenant per namespace, or we have another approach where we want to have different clusters for each tenant, or multiple clusters for each tenant. And when we do that that second approach where you have clusters, multiple clusters, this means that you are duplicating your control plane nodes. So either physical servers for control plane, dedicated physical servers for your control plane, and then you have dedicated worker nodes attached to these control plane nodes, or you have virtual machines, and you have again dedicated virtual machines for your control plane, and then you have dedicated workers attached to this control plane. So we changed a little bit our approach here, and what we did was we first start by building what we call the management cluster. So the management cluster is a Kubernetes cluster. It is k0s basically, and this cluster is also called mothership, right? And we deploy that using the methodology that Roman explained. So either we use Terraform, and then we use k0s Scuttle to deploy all the k0s services, or we just log into these machines and we just download the k0s binary and we start the k0s binary service, right? And you have that given management cluster. And then within that management cluster, we deploy a k0s Motron controller. And through that k0s Motron controller, we'll be able to deploy k0s control plane, but this time as Kubernetes pods, right? So all the control plane elements will be deployed in, let's say, a given namespace as Kubernetes pods. So instead of having virtual machines or physical servers to host your Kubernetes control plane services, all your Kubernetes control plane services will be hosted in that mothership as pods. So that's step number one. And then you will also leverage cluster API. So we have a cluster API controller. And through that cluster API controller, we will be able to set up the worker nodes and then attach these worker nodes with the k0s control plane, right? So we are automating all these different steps so that you have that concept of mothership. Within that mothership, you have dedicated control plane services for each of your Kubernetes cluster. And then the only thing that you are at the end of the day virtualizing or having dedicated physical nodes are your worker nodes attached to these containerized control plane. And you have the various use cases where it is interesting to do that. Whenever you think of scaling the amount of clusters that you are going to provide to your customers or your tenants, or you're going to use yourself, then this is a nice approach, because again, you don't need to demultiply the amount of nodes, whether physical or virtual, to handle your control plane services. So that could be a use case. Another use case where it is interesting is you can mix your different environments. So nothing prevents you to have worker nodes, for example, in a given data center, and another worker node in another data center, or a worker node in physical machines and other worker nodes as virtual machines. So for example, as a very simple example, you can have a worker node in Hetzner, for example, physical machine, and then you can have another worker node in AWS as an EC2 instance, both running k0s and both attached to the same control plane layer, right? So you can think about these different options, where you can then have load balance your application in a single cluster, but across different cloud providers or across different vendors. Okay, so that's a typical use case. Another use case is when it applies more to the edge. So for example, you would have your central site or your POP, where you will have your management cluster. And then to all the different edge sites or 4 edge sites attached to this POP, or that central site, you will be able to deploy one single worker, multiple workers, right? And you don't need then to have dedicated resources, but whether virtual or physical, in these edge sites, because again, as Roman said, we don't have enough space, we don't have enough power in these sites. So you want to centralize everything and manage all these in an easy way in that given management cluster or mothership, right? And you can do that all using APIs, or you can do that using YAML files to control everything in terms of deployment, in terms of scaling, in terms of updates and upgrades. Because again, you under the hood, you have these controllers, k0s controller and cluster API controller, right?
Thank you, Daniel.
Yeah.
So now I think we can proceed to the demo. So for the demo, I will use Lens Desktop. It is essentially, it's just the UI for your Kubernetes cluster. And it is working with k0s also, which is really cool, in my opinion. So here you can see that my cluster consists of 3 workers. And also I have 1 controller, but k0s hides, the controller node from the, so you can't schedule any workload on the controller node by default, but you can also configure this to, to have controller node as a scheduled node. Yeah, so I've already installed Multis and KubeVirt on top of this cluster. And let me first show what KubeVirt essentially is. So basically, it is just the Kubernetes controller. So just the workload, basically. And with the help of this tool, you can spin up a VM, for example. So let me copy this example. So this is definition of the virtual machine. So you see it is using KubeVirt API group, and the kind is virtual machine. So you're giving the name, you give the name to this virtual machine and specify everything like it is like the virtual machine, or at the same time, it is a pod. So we will be using Ubuntu here, and let's press enter. And we see that my virtual machine is created. And also, like, this is think about Lens Desktop. So you can use CRDs, so custom resources, right here, and we can easily see that we have virtual machine called Ubuntu Bionic here, but the status is stopped. So we need to manually start this VM. So we can do this by executing kubectl virt start and then the name of the VM. So we can see output that this was scheduled to start, and we see the status here is starting, and it is creating a pod in the default namespace. So you can see it here called virt launcher. It is starting. It probably will take some time, not really much, but a bit. And let me while it's starting, talk a bit about Multis. So we can directly mount, for example, nodes, like worker nodes, network interface to a pod. Oh, okay. So it is running. So let me come back to the keywords. So we have it running. So you can treat it as a pod, but also you can think about this as a VM. So what you can do is you can access the shell of this machine. So you basically need to type console, kubectl virt console, and then the name of the VM. Okay, let's give it some time. And let me come back to the mobile spot once again. Yeah, as I said, sometimes you want to mount a node's network interface to a pod, and you can use, for such purposes, host device CNI. And you need to define, like, network attachment. It is like CRD, like custom resource created by, defined by Multis. And I already did this, so it is pretty easy to understand what it is about. So it is just the configuration of the CNI. You specify the version of it, specify type, and also device. So I previously created on one of the machine device, and its name is ENS7. You can see like the subnet that I defined for this device here. And basically what we will do now is attach this network interface to a pod. But also we have another definition for the network attachment. It is MacVLAN. And essentially, looks kind of similar, but you see that here we are using MacVLAN CNI and also another subnet. So we will connect two different networks to the same pod. And to do this, we just need to specify annotation for the pod creation. You see here, we're specifying this annotation and what network attachments we will be using here. And also you can see here that I specified the node name because I created ENS7 network interface only on this node. So we can see that this pod is up and running. We can enter it. So we are just basically doing exec inside the pod. And we can see here that we have three interfaces. One is the standard one that is assigned by default by k0s control plane, and also two more. This one is for the ENS7, and this one for the MacVLAN CNI. So right now we have three interfaces inside one pod, and we are obviously can access this network, and also this network as well. But by default in any Kubernetes, your pod will only have this interface. So this is internal cluster subnet. But with Multus, you can extend this functionality and have another networks attached to your pod. Okay, so this is about this was about Multus. Let's try to come back to our VMs. So this is essentially how Kubernetes is working. So we have a pod that is using host resources, and inside that pod you can execute wish which will show you all the VMs that are created on this host.
Yeah, while it is starting or restarting, Roman, can you show how actually you installed KubeVirt and explain why this is out of the box and we didn't need to patch anything?
Yeah, so basically what I did, I just used KubeVirt manifests. So you see we have KubeVirt namespace, and we have like virt handlers, which are workloads that are running on every worker. You see worker 1, 3, and 2. And those things are handles all the virtualization stuff. And we also have like a couple of controllers and operators, which is used to do all the logic stuff of the creating virtual machines. And obviously we have Virt API. So yeah, this is like super simple solution. I mean, in terms how it works. But yeah,
and
so
did you need to patch anything, or you just use the
Oh, I just opened just opened the official documentation of the KubeVirt and just follow the installation guide and just install it out of the box. Yeah. So this is exactly you don't need to patch k0s binary or do anything like that. It is working out of the box.
Okay. And what about Multus then? Is it the same?
Yep, it is the same. So I mean, all the things that you need to Multus to work, it's a couple of workloads. It's also running on every worker node. And yeah, obviously you need to configure this network attachment. It's a bit tricky, but it is if you spend like some time, you will understand how to do this, and you can easily attach any, any interface that you want or any subnet that you have on your work nodes. So yeah, it is also working out of the box. You don't need to patch anything. You need to configure anything. I just followed again the official documentation on the Multis website. So
okay, and I do remember that with Multis you can download various network backend or network plugins. So here we are using MacVLAN as an example, but you also have host device as another one. One very popular one in the telco space is SOIOV. And actually the requirement for Multis comes from the telco space. The reason for that is there is a separation between the different services layers. So for example, management plane will be on a given interface, control plane will be on another one, and then data plane will be on another one, right? So that's why one of the limitations we got at the beginning of doing container network functions, CNFs on top of Kubernetes was, we had only one interface, and that was quite limiting. So there were a couple of plugins that were created, like CNI Genie at some point, and then now Multis is one of the main one. So as from there, you would deploy Multis, you would install the plugins, you can cherry pick the plugins, and then you will be selecting multiple MacVLAN interfaces. You can use your default one, whether you want to use Calico or even Cilium. Cilium is also one popular one, simply because it allows you to do some high level, quite complex traffic control, like egress gateways. You can manipulate that without having to install Istio, for example. You can also manage network policies in a more convenient way because the way that it handles all the metadata or tags around some of the Kubernetes objects. So that's some of the advantages you have with Cilium. So you can use that as your primary interface, and then you use a MacVLAN for, let's say, the control plane, and then you use SOIUV, for example, for your data plane. And in that case, what will happen is that your operating system will just attach or detach one of the virtual physical interface, so one of the SOIOV VIF, from the host, and will reattach that to the pod, right? Even for host device, you can see that if you just look at your operating system, every time you're spinning up your pod where you have selected or you have indicated in your annotations your physical device, your host device, you will see that the kernel is detaching from the host the physical interface, and you can see that it is reattaching it to the to a pod, right? And when you close that pod or you remove that pod, it is being reattached to the host operating system. So that's how it works. In terms of troubleshooting, again, you would need then to look into some of the logs from the host operating system. You will need to look at some of the events in Kubernetes, and then also you can look at some of the events around the pods, right? So it can be quite complex, right? But except if you know where to look like. But SOIOV, whether it is virtual machines or pods, at the end of the day, it's the same principle. You can then mix that with the concept of Convert. So you can have multiple interface also attached to your virtual machines, right? Because again, in the Kubernetes world, a virtual machine which is handled by Convert is an application which is being scheduled. Now, instead of being a pod, it is a container. In that case, when you will log into your virtual machine, you will then be able to see multiple interfaces, the same as in your pod, depending on which devices you have selected, right? Roman, I see that you have been able to troubleshoot and see what was the issue around your virtual machine.
Yep, I just missed one configuration line, and because of that, it is not working. So we have, as you can see, this virtual launcher pod running in the default namespace. And this pod is managing the VM that is running on the host. So as you can see here, we can log into this VM. So, and also like name of like the login and the password, we can specify it in the VM configuration. Let me log in. And as you can see, it's just the default Ubuntu shell. What we can do here is type this thing, and you can see that it is Linux Ubuntu Bionic and the version of kernel and all that stuff. So this is basically the VM that is managed by k0s. So you can schedule any VM if your worker nodes has if your worker nodes have enough resources in terms of memory and storage and CPUs, then you can create a VM on top of this of those worker nodes, and you can use it. You can treat it as as just the VM. So like as you're doing it with the classic standard virtual machine, you can do all the things to this VM running managing by k0s. So
yeah,
this is
and you have the full control on that VM because you have the same objects or the same verbs that you can use. Like for example, annotations is one example, but you can also select where you want to deploy that virtual machine. You can define a replica set for that virtual machine so that if that virtual machine for whatever reason fails at some point, the replica controller will respawn that virtual machine. You can use the node selector to also pinpoint that virtual machine to specific nodes where you need specific resources like GPU, for example, right? So you can leverage the same capabilities as what you would be doing for your pods. One very interesting point also around KubeVirt here is that the way that you are defining, so the YAML file that you are using to define your virtual machine is a very standard way of defining these virtual machines using the Kubernetes concept. If you are going to use, for example, OpenShift, you will see that there is a difference in the way that you will need to deploy your virtual machines in OpenShift, because there are some very specific verbs that only applies to OpenShift and not to standard Kubernetes. So in this case, with k0s, you are in a standard Kubernetes. If you are going to use the same thing on another Kubernetes distribution, right? Let's say you are going to do it on a do-it-yourself Kubernetes, vanilla Kubernetes, it's going to be a one-to-one comparison. You can take that YAML file and use that indifferently between k0s and your vanilla Kubernetes. But if you are going to migrate all your workloads from OpenShift, for example, to Kubernetes, then you are going to see some differences in the way that you need to define your workloads, because there are some specifics around OpenShift.
Yep. Thank you, Daniel. So for the demo, that's it. Yeah, and also we have some another webinars coming, and one is exactly about Cosmotron that Daniel was talking about. So please attend if you can. I believe it will be pretty interesting thing. And also we have another one about Kubeflow. It is about AI on Kubernetes, so it is pretty interesting too.
And again, these are open source projects, so do not hesitate to contribute, right? You're more than welcome to get into the GitHub projects, contribute code, documentation, tests. If you want to try some specific scenarios and publish that, we are very happy to see and exciting to see how the community is actually using k0s and k0s Motron. So thank you very much, everyone, for your attendance. I hope it was useful for you. If you do have any questions, please reach out to us at mirantis.com, and we'll be happy to give you any more information.